Moving on in our theme of real numbers and algebraic thinking. And now we're going to start looking at the concept of variables in this section. Variables are basically a generalization of some type of pattern. If we were able to use an actual variable and actual value instead of the variable, then it's going to limit the situation to that one instance. And so variables are helpful because they help us describe multiple situations or multiple instances. It's also going to be an element of a set. So you're going to have a set of values that could be plugged into a variable. Here are some examples of translating statements into an algebraic form. 2 more than a number would be the number plus 2. Square root of 2 greater than a number would be the number plus the square root of 2. 2/3 less than the number is going to be the number minus 2/3. 2 times the number would be 2n, and a number times itself would be n squared. Now, if I want to start looking at longer statements in part A, I'm going to have 40 times n dollars because n here is going to be the number of days that you rent the car. So if I was trying to generalize a formula, now I can know the amount for 2 days, 5 days, or even 10 days just by plugging into the expression. If the car is traveling at a constant speed of 65 miles per hour, the distance that it travels would be 65 times h. That's how we're actually doing the math of coming up with the number of miles traveled over time. And here with the DVD situation, we would have 2 times the D of, like, not DVDs, but the 2 times the lowercase of the letter D, because I have a full-size DVDs were sold, twice as many CDs are sold, and then I've got, that implies the 2D there. So if I do 25 fewer than the CDs, I'm going to have 2D minus 25. French fries have about 12 calories a piece. So if I'm trying to convert this to if he ate some quantity of fries and a hamburger, how many more calories did he consume that day? Well, first I'm going to have to figure out what's going on with the French fries so that I can then generalize it to a wider frame of reference. Then I'm going to have to find out how many more calories he consumes and subtract that from the 2,000. So I know that one French fry is 12. So that would be 12 times the number of fries he eats calories. Then I know that I'm going to have the hamburger to add into here, so that's 600. And so the number of calories left for the day would be expressed as 2,000 calories, that's what he has for the day, minus the 600 for the hamburger. And then I'm going to add the quantity of fry calories to the hamburger itself, then get that subtraction statement to get the final answer. Here's another example of a word problem. So in this time, I have a teacher working with things, and I'm analyzing the instructions here to see how the teacher is able to determine the original number from what's given in this. So you can create a table here to help you with the actual algebraic work, and to get to that final algebraic answer, you're going to take it step by step. So the discussion area is each step that we're getting to figure out that actual bottom expression. So here, we could use the work backward strategy from the expression, and we could actually reconstruct it to solve for what we have. And we will know the original number is 1 less than the result, or the result is 1 more than the original number. Here I have an example, and I like this example because I've got these shaded tiles. And so if I'm looking at what's happened with these shaded tiles, it looks like there's something going on here that's exponential. Because I have 1, and then I have 2 squared is 4, and 3 squared is 9. So that's kind of triggering what's happening there. How many shaded tiles are there in the nth figure? Well, I knew that they were definitely using exponents, and they were squaring because I went 1, 2, 9. So that means it has n squared shaded tiles. Then if I'm looking at the white tiles, that's going to be a little bit different. So that reasoning is on the slide, and it would be my n plus 2 times 4, and then I'm going to take away the number 4 based on the explanation there. If I'm doing an arithmetic sequence, so remember from our past, an arithmetic sequence is when I add the exact same number or subtract the exact same number from every term. So that expression, when we were actually looking for the term values, we had this formula we used where we use the common difference. And so this is the formula that would be used if I was trying to generate this arithmetic sequence. So I would know my common difference is 4. I'm going to plug 4 into the equation to find my first term. So my first term has to be 7, and that should make sense because if my term is 11 and I subtract 4 from 11, that's going to give me 7. If I wanted to find the 100th term, I'm going to go in and do the opposite and then just go ahead and plug in 100 for n instead of trying to solve it for the a value. Here is a geometric sequence. Now remember, geometric sequences are different. That is when you multiply or divide by the same number with every term. The number has to be the same. So if I look at this ratio, they're multiplying everybody by 3/2. And this is the formula for a geometric formula. The common ratio is the 3/2 that everything's being multiplied by. And then I'm going to have my initial term of 2, and I'm going to have n minus 1 for the exponent. If a geometric sequence has the first term of 3 and a ratio of the square root of 2, we're going to use that exact same formula. So the square root of 2 is my ratio. It's going to go in parentheses. And I'm going to do the term minus 1. So if I want the 10th term, I'm going to plug in 10 for n. But when I subtract the 1, that gives me the 9 value. And I'm going to simplify that. And I'm going to get 2 times 2 to the 9/2, which I can keep simplifying until I get 48 over square root of 2. Another example is this one from the local farmer's market. We're looking at the costs of each object given the 3 different groups that I have. This pops up a lot on social media too. Suppose the objects in the first 2 purchases are put together. So I'm going to group those together. They both have flower pots. So my assumption is I have to be able to kind of figure out the flower pot. If I look at them together, I know that the cost for the 2 vases and the cantaloupe and the watermelon is $17. So if I'm looking at this, I'm going to basically rule out the information that I'm given until I start looking at the cantaloupe cost somewhere between $5 and $8, or 8 minus 5, and that gives us 3. So if I'm looking at that range, I've got a $3 rough idea. The watermelon is going to be the 9 minus the 5, which is around $4.